Greetings, mathematicians. It's Mrs. Marcellus in Baratosthenes. We're still here in Bermuda having a grand time. Now that Baratosthenes is feeling very confident about converting among fractions, decimals, and percents and feels that he has that Math Bermuda triangle tackled, we've decided to move on and do some different problems where we apply what we've learned. In this lesson, we're going to compare and order fractions and decimals and percents. You notice here that it says Part 1. For today, we're only going to tackle fractions. Today's learning objective: students will compare and order fractions, decimals, and percents by converting them to a common format and applying their knowledge of place value and equivalent fractions. When we are comparing two numbers, we use three different symbols. The first symbol is greater than, the second is less than, and the third is equal to. When these symbols are placed between two numbers, we read them from left to right. Let's move on and try our first problem. When we are comparing two fractions, we want to determine whether or not the first fraction is greater than, less than, or equal to the second fraction. There are multiple ways to do this. One way is to find a common denominator. If the two fractions have a common denominator, then you can compare the two numerators to determine which one is larger. In this case, if we have the denominators of 3 and 9, a common denominator would be 9, because both 3 and 9 go into 9. That means we have to convert the fraction on the left to an equivalent fraction with a denominator of 9. I multiply times 3 and multiply the 2 times 3 as well, and we end up with 6 over 9. 6 is greater than 5, so the first fraction is greater than the second fraction. And many of you probably learned that the mouth opens to the larger value. It's hungry and wants to eat more. This means that the mouth would open towards the 6. 6/9 is greater than 5/9, so 2/3 is greater than 5/9. When we did the problem the first time, we had the least common denominator, which is the least common multiple of the two denominators. However, if we find just a common denominator, we can still make equivalent fractions. One way to find a common denominator is to multiply the two denominators. 9 times 3 is 27. So let's take a look at what would happen if we use 27 as our common denominator. We would have to convert both of the fractions to a number over 27. In order to do this, we'd have to multiply the left side times 9, which gives us 18. And on the right, we'd have to multiply by 3, which gives us 15. Since 18 is larger than 15, the first fraction is greater than the second. Now, if we look at this a little more closely, you'll probably notice that in order to get the numerator, we multiplied by the opposite denominator. For example, on the left side, on the top, we multiplied by the opposite denominator of 9. On the right-hand side, we multiplied by the opposite denominator of 3. So 9 times 2 gave us the 18, and 3 times 5 gave us the 15. This is called the cross product. When comparing two fractions, we can always multiply the numerators times the opposite denominators and get two numbers to compare. We don't have to go through the bother of finding the least common denominator or even writing a common denominator. And it would look like this. When comparing two fractions, we can simply cross multiply. You always have to start with the denominator and go across to the numerator and write the number on top. 2 times 9 is 18. Then 3 times 5 is 15. This is the same thing as converting the fractions to 18 over 27 and 15 over 27, but you don't have all the clutter. Then we compare. 18 is greater than 15, so the first fraction is greater than the second. It's really important, though, that you start at the bottom and multiply across to the top and write the numbers above. If you do it in the opposite direction and start with the numerator times the denominator, all your answers are going to come out backwards, and that's not a good thing. There is a third way that you can compare the fractions as well. We know that every fraction is a division problem. So we can turn the fractions into decimals. 2 divided by 3 gives us 0.6 repeating. It goes on and on and on. And 5 divided by 9 is 0.5 repeating. Since 6 is greater than 5, 2/3 is greater than 5/9. Let's try some more examples now that we have some different ways to solve them. Since the cross product is usually the easiest thing to do, I'm going to stick with that. I also will show comparison of the fractions written as decimals. In this case, to find the cross product, I would multiply 5 times 7, going across and up, which gives me 35. 9 times 4 is 36. 35 is less than 36, so the first fraction is less than the second. Now, if you don't like to have all that clutter, it's not necessary to draw those arrows. If you'd like to write these in decimal forms, 7 divided by 9 is 0.7, repeating, and 4 divided by 5 is 0.8. So again, we can easily see that the first one is less than the second. Let's try another example. You can always find a common denominator or simplify one fraction to see if it equals another, but I'm going to go ahead and go with the cross product. 18 times 1 is 18. 3 times 6 is 18. 18 is equal to 18, so these two fractions are equivalent. If I took the numerator divided by the denominator, I would find that 1/3 is 0.3 repeating, and 6 divided by 18 is also 0.3 repeating, which also shows the fractions are equivalent. When you have a mixed number, the same methods still apply. The first thing you want to do, though, is to compare the whole numbers. If the whole numbers are equal, you then need to move on and compare the fractions. If one of the whole numbers is greater than or less than the other, then you don't even have to worry about the fractions. You already have your answer. We still can do our cross product, so we multiply 8 times 10, and we get 80, and we multiply 11 times 7, for 77 on the other side. 80 is greater than 77, so the first fraction is greater than the second. If I want to convert these to decimals, 10 divided by 11 is 0.9090, and it goes on and on and on, but 7/8 is 875 thousandths. When I'm comparing the two decimals, 9 is greater than 8, so the first decimal is larger than the second. Next, let's put a set of fractions in order from least to greatest. We can do this a couple different ways. One of them is to find a common denominator, make equivalent fractions, and then compare the new numerators to determine the order. To find a common denominator, we'll start with the largest denominator, 14, and see if the other values go into it. In this case, 14 won't work, because 4 does not go evenly into 14. Next, we try multiples of 14. So 2 times 14 is 28. Then we check to see if all the other numbers will go into 28, and they do, so that will be our common denominator. We'll need to make equivalent fractions. So for the first one, we start with 28, and 4 times 7 is 28. So 4 times 5 is 20, and that gives us our new numerator. 2 times 14 is 28. 9 times 2 is 18. So 9/14 equals 18 over 28. 4 times 7 is 28. So 3 times 7 is 21. And then finally, 2 times 14 is 28. 1 times 14 is 14. We now have an even playing field, so we can compare the numerators to determine the order of the fractions. 14 over 28 is the smallest, so that means 1/2 is the smallest fraction. Next, we'll go to 18 over 28, which means 9/14 is the second smallest. Then we compare 20 to 21, and since 20 is smaller, 5/7 is the third largest fraction, and the largest fraction of the group is 3/4. We can also order the fractions by turning them all into decimals and then comparing the decimal values. We know that every fraction is a division problem, so it's really easy to turn them into decimals. 5 divided by 7 is 71 hundredths, and I'm just going to round to the nearest hundredth in this case, although sometimes you might have to go to the thousandth or beyond to compare. 9 divided by 14 is 64 hundredths. 3 divided by 4 is 75 hundredths, and 1/2 is 0.5, and since everything else is hundredths, I'm going to write 0.50. Then we compare the decimal values. The smallest number is 0.50, so 1/2 is the smallest fraction. Next comes 64 hundredths, which means 9/14 is the second smallest fraction. Next we find that 71 hundredths is smaller than 75 hundredths, so 5/7 comes next. And then finally, the largest value is 75 hundredths, so that means 3/4 is the largest fraction. There are other ways that you can order the fractions as well, but these are two of the easiest and most efficient. Well, Veritasians, that completes part 1 of our lesson on comparing and ordering fractions, decimals, and percents. How about we do some souvenir shopping and come back and finish the rest later? Sound good? Okay, well, bye for now, math students.